Hi friends, today we are going to discuss the role of solvent in deciding the path of a mechanism. That is, again, we are talking about the competition between SN and elimination. And we are going to discuss the role of solvent in deciding whether the reaction will proceed through nucleophilic substitution or whether it will proceed through elimination. Let us take a simple example to illustrate this point. Let us consider two reactions of ethyl chloride. In one case, ethyl chloride is treated with KOH, which is aqueous, that is prepared in water. What we get is a hydrolyzed product, C2H5OH and ACl. However, if we carry out the same reaction, ethyl chloride only, but instead of aqueous KOH, if we choose KOH as alcoholic, that is prepared in alcoholic solution, alcoholic medium, what we will get is elimination, which will result into formation of alkene. So the first reaction is proceeding through an SN2 mechanism, whereas the second reaction is proceeding through E2 mechanism. The only difference here is KOH being aqueous and KOH being alcoholic. This goes without saying that it is only the nature of OH minus, whether in water or whether in alcohol, that is making all the difference, and that is deciding which path will be followed by the reaction, whether SN or whether E. Let us discuss this in detail now. Both water and alcohol are capable of forming hydrogen bonds. However, the hydrogen bonds in water are much stronger than hydrogen bonds in alcohol. This, I think, all of us are aware, no need to go for further explanation. So hydrogen bonds in water are stronger, and therefore in aqueous medium, if you consider OH, and in alcoholic medium, if you consider OH minus, in aqueous medium, the strength of the hydrogen bond which binds the OH is strong. That means OH is solvated to the greater extent. Of course, it means that OH minus is less available, or its strength has been reduced because it is bound. Compared to this, OH minus in alcohol is stronger because it is bound by hydrogen bonds of alcohol which are weaker. Again, I am saying compared to water. So compared to water, OH minus in alcohol is less hydrated, or we can say it is stronger. So OH minus in alcoholic medium is stronger compared to OH minus in the aqueous medium or in water. We have understood this. Now, what is the main concern or main interest of a base? The main interest of a base is to somehow catch hold of H plus ions so that it can neutralize and form water. This is what exactly happens when OH minus is strong. When OH minus is strong and when you treat it with ethyl chloride, this OH minus extracts a hydrogen. At the same time, the bond shifts here and chlorine goes away as a leading group. This, you can see, results into shift of bond here, and what we will get is CH2, double bond CH2. This is the E2 mechanism that we have discussed. Please see here, OH minus has two choices. Either it will extract hydrogen or it will go to this carbon. OH minus is also a nucleophile. You can see the bond between C and Cl is polar, with a slight plus delta on C and a slight minus delta on Cl. OH minus also has a tendency to go to this carbon as it is a nucleophile. But when there is a competition And when OH minus is stronger, it will ignore this C plus delta and it will attack this H. Whereas, if this OH minus is weak, as in case of water, it will not be able to extract hydrogen here. It will choose another path. It will try to go to the carbon as a nucleophile and it will proceed to SN2 mechanism. Let us see what will happen here. When OH minus is aqueous, this OH minus will go here, will displace this bond, and what you will get is CH3, CH2. As OH comes and Cl goes away, what you will get is CH3, CH2OH, which is ethanol happening in aqueous OH minus. Just to summarize, we can say that when OH minus is prepared in an alcoholic solution, it's a stronger base. It will have the natural tendency of extracting H plus, resulting into E2 type of elimination. Whereas OH minus ion prepared in aqueous solution is not so strong because it is bound by stronger hydrogen bonds that makes it a weaker nucleophile. Again I am saying compared to OH minus in alcohol. In that case, OH minus will go to carbon because there is a plus delta on here and minus delta on here. The bond is polar. As it is a nucleophile, it will go to nucleus loving. It will go to the positive center, and this will result into SN2 mechanism, where bond between OH and C is formed and bond between C and CH is broken simultaneously. And therefore, we get an alcohol with aqueous KOH and we get an alkene with alcoholic KOH via elimination mechanism. So the last sentence that I want to say here is that when OH minus is alcoholic, it prefers elimination, and when OH minus ion is aqueous, it prefers the SN or nucleophilic substitution mechanism. There is one more effect, that is one more thing which plays an important role in deciding the mechanism whether to follow E2 or whether to follow SN2 or SN1, and this is temperature. The temperature decides in some cases whether the mechanism will happen via E2 or elimination or whether the mechanism will happen via substitution. That we are going to discuss in the next part. Thank you very much.